Hello, welcome to the Computer Science Channel. I'm your host, Professor J.P. Baugh. Today we're going to be talking about variables and data types in Java. So in this lesson, I'm going to open up NetBeans, which is a free Java IDE or integrated development environment that you can download very easily. Just search on Google for NetBeans and try to get the most recent version. You don't need a ton of bells and whistles to start out in Java, so just pick one of their more simple varieties. You don't need the Enterprise Edition, but you can download that if you wish. Also, if you have Eclipse, that is fine, or IntelliJ. There's a host of other Java IDEs that you might choose to use. So what we're going to do first, at least in NetBeans, is go to File, New Project, and we're going to create a new Java project. So you'll have a similar workflow in most of the other IDEs as well. So even if you're using Eclipse or IntelliJ, you're probably going to end up having to create some sort of project, and you're going to pick Java or Java application or something similar to that. If you're using something a little more simple like JGrasp, or just compiling from the command line, you still should be able to follow along pretty easily. The code's going to be essentially the same, so it doesn't matter what IDE you're using, but I'm going to use NetBeans just because it's so popular and it's easy to use and it's reasonably efficient. So I click Next after I have Java Application selected. I'm going to select a project location now by clicking Browse, and on my desktop I've created a nice folder, specifically a work dir or working directory. That's what I choose to name it. It's very common for developers to do that. I'm going to hit open on that to make sure you're putting it somewhere where you know where it is. Now when it creates a project, it will create a special folder and subprojects as well. So we're just going to call this project name Java 1 or Java I for 1, whichever you prefer. And then I'm going to put a hyphen or minus sign, and then we're going to put variables and data types. Okay, so I'm going to hit finish. After I uncheck create main class, I usually just delete this because I want to create my own and have just a blank project to start with. So you can click finish at this point, and it will create your new project. You will see it over in the projects pane over here. I can expand that little node there, and you'll see that you don't really spend much time in the libraries, but you will spend time in source packages and default packages right here. Now a package is just to create a collection of classes. Now we haven't really talked about classes or anything like that, so we're just going to work with the default package, even though it's recommended, especially if you have large projects, that you create your own package. We'll talk about packages later on in the courses that we'll work on. So I'm going to right click default package, and I'm going to go to new Java class, and everything in Java is inside an entity called a class. What we're going to work with now is we're just going to call it variable fun. Okay, so class name variable fun. You cannot have any spaces in here. If you do that, it will tell you the class name is not valid. If you put any special characters or numbers in the front, so if you put a number in front, that's also not valid. You have to have what's called a valid identifier for your class. Usually if you stick with upper and lowercase letters like this, I use title case, so I start with a capital letter for my classes and then keep writing, and then if I have another word in the statement or title that I'm trying to make, I capitalize that too, so it kind of stands out. So variable fun, we'll start with that. I'm going to hit finish. So it usually adds some JavaDoc and other comments at the top. I usually just delete those. We'll talk about comments and everything else like that as we go along. Inside of this, though, this is a public class variable fun. The name of the file, variablefun.java, a .java file, contains Java code, just like a .txt file contains regular text, or a .docx contains a Word document, .pptx is a PowerPoint document. So everything generally uses an extension when we're dealing with Java. But at the end of the day, it's just a plain old text file. Now this IDE, NetBeans, IDE or Integrated Development Environment, allows us to compile or build our project so that the code that we're going to write in Java can be interpreted, run by the Java virtual machine. So you have to have what's called the Java virtual machine installed on a system in order to run code that was written in Java. So inside here, public class variable fun, I'm going to create the entry point to our program. Public static void main string, and then you have an open and close square bracket, and then usually we name that args. Okay, ARGS, but you don't have to. You can give it any valid identifier. Again, we'll talk about identifiers as we go along. At the end of this curly brace, this is not necessary, but I usually put what's called a comment. This is not code. It is something that's to remind me of where the ending curly brace for main is, but NetBeans also does a good job, and most IDEs do a good job about doing syntax highlighting, and also highlighting things like the curly braces. When you touch them, it'll show you which ones line up. So if I touch this one down here, it lines up with this one up here. Well, main, if it has this exact signature, public static void main, and then it takes string, brackets, and then args or whatever. This can vary. This doesn't have to be the same, but as long as it takes a string parameter, this is the entry point to your program. So inside here, we can just do something very, very simple just to start off. Before we get into variables and data types deeply, I want to just print a line to the console. Okay, so I'll say hello world right there. There's a very basic obligatory program that you write in a lot of different environments. So system.out.println hello world in double quotes. The double quotes are necessary. You can't leave them out. That is called a string literal, which is being passed to this method called println. It's basically a little machine that does some work for us. It's going to print this line of text that we're telling it to the console. And you'll see what the console is in just a second. So if I hit the run button, it could ask me what it is. I could also go to right click here and then go to run there. I usually do that. So right click the name of the file that I want to run and go to run file. And you will note once it gets done compiling, we're going to see the output. So we have to give it a couple seconds. It usually takes it a little while to warm up, and that's exactly what we see down near the bottom. It says run and then hello world and then build successful. Now we didn't write the code to print out the run statement or the build successful or anything like that. That's added by the IDE. Hello world, on the other hand, is what we said to print out. So that's a very, very basic thing that you can do. Since it's print line, that means that it's printing and then putting a new line afterwards. So if I put another print line statement afterwards, and then I run it again, right click, run file, it'll say hello world. It prints a new line character at the end automatically and goes to the next line, says hi there, and then prints another new line there. If I leave the ln off, let's see what that does. Just say system.out.print. Now if I run it now, you'll see it's a little bit different, right? So it'll say hello world, and it'll immediately print hi there. That's because it did not print a new line character at the end of this string literal right here. It went straight to this statement right here. This printed out hi there with a new line. That's why build successful is on another line. Now if we take the ln off of this one, right click and run, you'll notice that the whole thing's pretty much on this line now, right? So it says hello world, hi there, and then there's no new line character, so the build statement is actually on the same line. So normally, to keep things clean, a lot of times you're going to want to put print line. So those are two different types of methods. They're called methods that you can use to print out text to the console. Okay, those are the primary ones that we're going to be using. There's also another one called printf. So we're going to take a look at that. System.out.printf. Okay, this is called formatted strings. So we're going to put a format string at the beginning. and it's going to have these things called format specifiers in them, which are basically just placeholders for different data. We're going to start very simply here. I'm just going to put %s \n %s. Okay, now that's going to look really funny right now, but we're going to make sense of this in a moment. Then what I'm going to do is I'm going to put howdy, comma, and then world. Okay, and let's see what happens when I run this. Okay, run file. Now we have our hello world and our hi there from these two statements right here, the print line statements. But what about printf? Printf says howdy world, and you'll notice that after world there is no new line character. But why is there a new line character after howdy? Why did it go to the next line to print world and not print it on the same line? You might have guessed that's the \n. That's a special character called an escape character, escape sequence, that means new line. It means insert a new line. The %s is a format specifier, which means string. So string, new line, string. Now, where does it get this first string? Well, after the comma, the first thing it encounters is a string. That fills in this s right here, then the new line. So that's the howdy. That's where we get howdy from. Then the new line, then the other string. That's where this one comes from. Okay, so there are other format specifiers too. They're not all strings, or what we call character strings. I've been using the term string a lot, so maybe I need to clarify. This is one of many different data types. A string is a data type that holds multiple characters, or alphabetical characters, even numbers, or special characters inside of double quotes. So it's basically just treated as regular old text. Furthermore, we want to talk a little bit about data types in general, and also what are variables as well. So in here, we've basically just covered some very, very basic standard output techniques. So we've taken the standard output object, system.out, and then we've called the println method and passed the println method, for example, an argument of a string literal right here, and then we have another string literal here because we literally type a string, okay, it's as opposed to a variable, which we'll see in a little bit. And then same thing here. This one, on the other hand, takes 3 arguments in this particular case, because we have the first argument, which is the format string, and then we have all the values that fill in the format specifiers. So if we had another %s in here, we could put comma and then another string over here. So there's just different ways to do this. Now, that's pretty much what we need right now to know about standard output. But what about variables? So variables, I've mentioned a couple times. We need to really talk about variables and data types in order to really understand the meat of Java. Data types are, as the name suggests, the type of data that a variable can hold. And a variable is just a named location in memory. So on a computer, you ultimately have a lot of confusion about what does memory mean. So a lot of people say, oh, well, I have a really large hard drive, so I've got a lot of memory. That's not what that means. When people say memory, or someone who knows what they're talking about says memory or main memory, they're talking about RAM, or random access memory. This is the type of memory that holds information live while you're interacting with it, while the CPU or the processor, the brain of your computer, is interacting with it. As a programmer, you're concerned with a couple different things. You're concerned with data, which is the information, or the numbers, the strings, the characters, the trues, the falses, all kinds of different information you might want to keep in your program. That's the data. And you also have the algorithms, which are the instructions that act on the data. So, focusing in on data, we've got data types. So, one data type we have in Java is int. So that stands for integer. I'm going to give it a name, myInt, and then set it to the value 50. Okay? And integer are basically the counting numbers. They're whole numbers, and they're counting numbers and the opposites. So It's a integer is a whole number. It doesn't have a decimal point. I couldn't put 50.5 because that would not be an integer. Um, Another example, if I wanted to do a something with a decimal point, I could use a double. So I could say my double equals 3.1415, right? So that's part of pi, right? Okay, I could even name it pi if I wanted to because that's a valid name. So I could say pi right there. That is a valid identifier. So let's dissect this a little bit more. When I say int my int, that tells the IDE, tells Java that I want to declare an integer. So I'm declaring an integer, and I'm defining it on the same line by setting it equal to the value 50. So at the memory location, with the alias myInt, it's storing the value 50. So 50 is the value. 50 is the value that is stored in the memory location that this refers to. And the only types of data that can fit in this memory location, that can be held in this memory location named myInt, are integers. Likewise, I have a memory location whose alias is pi, and it can only hold doubles or real numbers. That's one of the types of real numbers that we have in Java. So these are two different lines here with both a declaration and an assignment operation. Okay, together we could call it a definition or an initialization of the value, because it's the initial or first time that the variable gets the value. You don't have to do it all on the same line. Let's say some other int. I set that I can put semicolon after it and then later say some other int equals 27. I can do that if I want to. So this line would be the declaration, and this line right here is the assignment, and the first assignment is also called initialization. Okay, so what can I do with these variables? Well, I could print them, so I could delete our friends down there, say bye. Okay, so I could say system.out.println, and I could just say myInt right there. Okay, and if I run the program now, it will print out the value 50. Okay, so I can also say in double quotes, I could say myInt is, and then with a plus sign there. So this takes a string literal, and it basically appends, or the fancy word we use in programming is concatenate. It concatenates the integer, converts it essentially to a part of the string, so it'll just look like I wrote a sentence. My int is 50. So if I run this now, I get the sentence my int is 50. Okay, so we've done quite a bit so far. So let's review a little bit. We've got the data type. So int is a data type, double is a data type. MyInt is the name of the variable, also called the identifier because it identifies the variable. Pi is an identifier for this double here. And some other int is an identifier, which we declare on one line and initialize or assign the initial value on another. Now, I could reuse these later on. I could decide I want to set some other int to a different int. I could later on say some other int equals 35. And if I print below here, if I say system.out.println some other int, this is going to print out, will it print out 27 or 35? You have to ask yourself that. And it prints out 35. That's because this happened in sequence later on. So in the control flow, as it goes through the program, when it gets to this line, it assigns the value 27 at that memory location. But later on, two lines later, one full statement later, we have 35. So it actually overwrites the value that was previously there. So again, we've got variables, like some other int, values, like 27. This is also called an integer literal. This is called a floating pointer double literal right here, 3.1415. This is called a string literal. So if you directly type in the values or obtain the values like that, then we call them literals. So that's literals and variables. So we kind of have an idea about what data types are, etc. You should know that there are 8 data types, 8 primitive data types in Java. There are 2 main categories of data types in general. There's primitive types and reference types. We'll get to reference types in just a minute, but let's focus on the 8 primitive types. So again, a primitive type is a variable that holds the value directly. So for example, this int in memory is just an alias for a memory address. It directly holds the 50 at that little, you can think of it as a little box that your computer can keep information in. Okay, so that is a primitive. An int is a primitive. There's tons of others. There's 7 others. So we've got in total 8. There's byte, which is, I'll give you one guess how large it is in memory. It's 1 byte, or 8 bits. If you're not familiar with this terminology, don't worry about it, but if you are, maybe it'll make more sense as we go along. 1 byte, a byte is 1 byte, so B-Y-T-E. Short is the second primitive, that is 2 bytes. Int is 4 bytes. And long is the last integral type, so it's 8 bytes. Okay, so byte, short, int, long, that's 4 types. We've also got 2 types that can hold real numbers. The smaller of the 2 is float, which holds 4 bytes in Java, and then double, which holds 8 bytes. So those, we've got byte, short, int, long, float, double, that's 6. We've got 2 more. There's char, C-H-A-R, for holding single characters, whereas a string is multiple characters like M-Y space I-N-T. A char data type can only hold 1 character. So if I want to create a character, I could say char my char equals, and then maybe capital letter A. Okay, it may seem like it has limited use, but there are reasons you would want to use this. But you'll learn that as we go along. So, excuse me, byte, short, int, long, float, double, char, and then the last one is Boolean. It's this mysterious type that can only hold 1 of 2 values. So we have Boolean, you spell it out. Boolean is raining. Okay, we'll just name it something like that, and we'll say true. So true and false are the only 2 values that this can hold. These are keywords in Java, meaning you can't, for example, reuse them as a name. I can't say int true. That I can't say I want to make an integer named true, because it's already a reserved or keyword in Java. Just like Boolean, you can't reuse that. They have meaning in Java. So int, Boolean is raining equals true. This helps us a lot when we start getting into control structures in Java, and we have to decide whether we want to do one thing or another, or whether we want to continue doing something. It helps our programs start to make decisions, okay, which is really where a lot of the power is. So I said there were 2 major categories. We've got the primitive types, where the variable holds the value directly. There's 8 of them: byte, short, int, long, float, double, char, Boolean. There's also the second category, which are reference types. Anything that isn't one of the primitives is a reference type. So the variable of a reference type actually contains a memory address of the location that the actual value or object lives at. This will make a lot more sense as we go along. So right now you can just think of the primitive types as directly holding the value, and a reference type as indirectly holding the value. So a string, we've talked about strings, so let's use one here. We've got string my name equals John Baugh. Okay, and then maybe I want to print it out later, so system.out.println. My name is, and then we'll just put my name. I'll use the variable name right here. And then when I run this, I get my name is John Baugh. So you can see that I can store this value in a variable, but string isn't one of the 8 primitives that we discussed. It's not a byte, short, int, long, float, double, char, or Boolean. It is a set of characters, we can think of it as, but it's not a char in and of itself. So this is actually a reference type. This is one of the reference types in Java. You can even make your own you can't make any more primitive types, but we can make tons and tons and tons of reference types. We will be doing that throughout this course. So you should review and learn the different terminology that we discussed today. And if you can try to memorize the 8 primitive types, just what they are, you don't have to fully understand them, but byte, short, int, long are the types that are for integers. They're types of integers, byte, short, int, long. So an integer, again, any of these cannot hold a decimal point part. They are only holding the whole numbers, the counting numbers and their opposites. There's also float and double. That's the numbers 5 and 6. Float and doubles are data that can only hold or can hold integer plus a decimal part. So 3.1415, 2.7111, 57.6, 106.3, whatever you want in those. And then char can only hold a single character. And then Boolean can only hold true or false. So those are our 8 primitive types. What's the other category? See, it's primitive, and then there's reference. Reference types don't hold the value that you assign it to directly. They hold a memory address. All reference types directly themselves hold a memory address, and then that memory address is the location where the value that the reference type represents lives. Okay, so we've got that. So you've got the variable data types. You've got identifiers, which are the names. Okay, they can't start with a number. They can't start with any special character except for underscore and $sign. I think that's it. And then you can put numbers in them. So if I wanted to put my int 1 here, that would be okay. But you just can't start them with 1s or 2s or 3s or anything like that. There's other things like %. You can't do that because that means something else. +, equals. That wouldn't make sense to put that in the name. So those are the identifiers. We also talked about how to output data to the console. So system.out is called the standard output object. Okay, so standard output object is system.out. Okay, and this output object system.out has methods such as print line, print we talked about earlier, and also printf. Okay, so that's pretty much what I have for you in this module, and we'll go further and try to look at what else we can learn in Java. So hopefully this has been helpful, and we'll see you again soon.